Alright, we're going to be working on 5.4.3, which is the Systems of Inequalities. Um, just to kind of go over the beginning, these videos are not meant to be like depth and breadth of the concepts. You guys have all sat through the course, you've all had the instruction, and then this is just kind of a compartmentalized version of all of this. So if you ever want more detail or need more help outside of the video, just reach out to me and we can find a way for me to support you. These are not meant to be all-encompassing videos. So some of them may be quick and short. So just if you ever need more detail, please just reach out. Communication is going to get us all through this. So let's rock and roll. All right, let's start. Which point is the solution to the system of inequalities? I'm going to go ahead and zoom in on this. What I'm going to do is I'm going to plot these points. So, ooh, I don't want that. Cool. I'm going to plot these points. There we go. Get my pen working here. All right, so I'm going to use blue for A. So it's 2, 0. So I need to go x value 2 and 0. These notches are going by 2, so I went one notch, but it works out to 2. I'm going to go orange as my B. It's 0, 2, so I'm 0, then I have to go down 2. Green, -2, -2, and actually I screwed that orange up. I gotta redo that. What did I do wrong with the orange? It's +2, not -2. 0, 2 is right there. There we go. That's a little bit better. And then we'll come down here to red, which is 0, -2, which is there. Alright, so the answer, which one is the solution? Well, which one is within the shaded region? So the solution to a system of inequalities is the overlapping shaded region. So that is just this area. So orange is my answer, B. You see how green's outside, red's outside, and blue is outside? They're outside of the shaded region. They are not a solution to this system. It's that simple. It's whatever's in this within the system. Now, if it was on this line, like from here to here, if it was on that dotted line, it would not be a solution because that is a dotted line. It does not equal to that line. All right, now, however, on these other lines from here to there and from there to there, those are solid lines. So if the point falls on that line, it is a solution. So a solid line, we include those answers. A dotted line, we don't. All right, let's go over here to, all right, so we'll start with orange. 2, 0, so I go +2, 0. That's not an answer, it's not in this solution set. 0, +4, so 0, 2, 4. I'm just plotting my points. -2, -2, well, -2, -2. I bet you that's going to be the answer right there in the middle of the shaded region. And then 0, -4 is right there. So again, our solution is the one that's within the shaded region, which would be C. Easy peasy, right and straightforward. All right, identify the region containing the solution. If there is no solution, right, no solution. All right, so what they do is they give us equations and they give us the graphs, and we just got to know which of these sections is correct. Well, what I'm going to do, right, we're just going to do a quick hitter here, is I'm going to type these equations into Desmos, right? We're allowed to use Desmos, so that's what we're going to rock out. Oop. So -x minus 4, and then we have, so I type that in. Excellent. So my blue line is shaded to the left, and it looks like they overlap in this section, which on our graph would be section D. So if I can get down here, D is going to be my answer. And we can kind of see it within the graph where, all right, red is shaded here, blue is shaded here, and they overlap on this section. All right, so we're looking for where they overlap, where the color kind of mixes is right here. We're going to do the same thing for 4. Pretty simple. Not trying to make this super complicated. We're doing it graphically. We're not really doing it algebraically. There is a way to do it algebraically. There's a way to do it by hand and all those different things. A lot of it has already been explained to you previously, right? So we're just kind of compartmentalizing here. All right, so purple, we got going to the right here. Green is going to the left. So the shaded region is in between the two lines. On our graph, that is labeled as B. All right, we got one more. Uh-oh. Look at this graph. Uh-oh. If we see we have these lines and they're shaded opposite direction, there actually isn't an overlap. Well, that would be the scenario where we have down here no solution, and that's just my shorthand for solution. So, no solution. So for these three, I just plugged it into Desmos and I was done with it. We don't need to make it too complicated. All right. Now the next questions are, oh, we need to choose which set is it. So there are horizontal lines here. So A is these two answers, B is these two answers, and C is these two answers. So how I'm going to do this, and I'll just do one of them, is I'm going to plot the equation. So if you look, like it's y equals 2x plus 1, it's just that the inequality sign is going to change. So because the inequality sign is going to change, that's fine. I'm just going to go ahead and write both equations. All right, so I wrote both because these are the two equations just like we have, and what we need is shaded in this region right here. All right, so we need shaded in this region. Well, let's look at answer A. Okay, so that's got to be less than, and then it's got to be greater than or equal to. Is that the right answer? Oh, actually might be. All right, so that is the right answer. Okay, I wasn't expecting that. So the right answer was A, right? It's the shaded region right here. So the green line, the solid line kind of going down is above. The blue line is going to the right below, and they overlap. They overlap right in the same section. And just to confirm that the other ones wouldn't have done that, I'm going to go ahead and try B. Right, so that is not the right answer. It does not overlap there. So I can just change these signs. I'll go ahead and I'll try C. Now C looks like it overlaps correctly, right? It looks like it has the correct overlap shading wise. Unfortunately, the difference is, and you have to pay attention to these key differences, is this blue line is solid. Well, that's the graph that should be dotted. And then this graph, the lower graph is dotted when it should be solid. So the reason why C isn't the answer is because the signs are just wrong, right? We got to make sure the correct equal sign is included. So you need to pay attention to make sure your solid line is solid and your dashed line is dashed. Right? That's the detail that'll be easy to miss, but it's also easy to correct. Just take that extra second. All right, I guess I'll go ahead and do 7. Shouldn't take me too long. So I'm just going to type in the two equations. So I got 3x minus 3, and I'm going to have y equals 1/2 x minus 2. All right, I'm going to do answer A. All right, so we're looking for this shaded region. So I'm going to go answer A, which is less than or equal to, and then greater than. So I go ahead and I do that. And as you can tell right off the bat, we are going the wrong direction on this line here. So A is not going to be the answer. So I'm going to go ahead and I'm going to just change the signs right away. So I'm doing B now. All right, cool. So, this graph's going the right direction. One problem though is this graph should be a dotted line, but it's solid. So right off, I'm paying attention to the line here. This should be a dotted line, but it's solid. So I need to so it can't be B. I'm gonna try C, which is just getting rid of the equal sign, and then adding an equal sign here. Well, actually, gotta change direction a little bit. All right. So now we have a dotted line. This isn't right. Did I miss one? Oh, no, we're good. This is right. dotted line goes to the left. Silly me. And then I have the solid line also goes above, right? And where do they intersect? Right over here. Right where we wanted them to. Good. So my answer in this case would be C, right? Just by plugging and testing those different numbers. All right, now we actually have a little bit more math to go here. All right, so Mrs. C's class is donating canned goods. So the girls have pledged they're going to bring in at least 20 pounds of canned goods. So what I'm seeing here is the girls, if I can find my cursor. There we go. So is bringing in at least. That's the key word to me is at least. At least 20 pounds, and that's the girls. Now, if the class brings in a total of 50 pounds or more, that's another important word to me. They qualify for a pizza party whenever it wants a pizza party. I'm not for that. So we have G for girls and then B for boys. So we know if the entire class, which is made up of girls and boys, brings a total of 50 pounds or more, that means whatever the girls bring, that's G, plus whatever the boys bring, that's B, has to be greater than or equal to 50, right? Because it's 50 pounds or more. So greater than or equal to, right? That's the entire class. Now, the girls specifically said they're going to bring at least 20. So the girls are saying that we're going to bring greater than or equal to 20 pounds. So we have our two answers there. Nice and easy. Now graph the systems of equations. Now one thing we have to change is we have to change these to x and y. So I'm going to make the girls my x and the boys my y. Alright, so I'm going to go back and they want us to graph it. Alright. Now, but instead I'm going to use my x and my y instead of my g and x just because Desmos doesn't recognize g and x. Alright, so x is my girls, y is my boys, and here is my equation, or my graph. Alright, and now, right, and they want us to sketch it, so we could sketch this graph on there if they want us to, but we're really not going to have to do that because we don't have paper tests, right? And now, use your graph from question 9 to select the point that would be a viable solution. So if we're looking for a viable solution, what I'm going to do is I'm actually going to plot all of these ordered pairs. Alright, so I'm just going to go ahead and plot them nice, quick, and efficient. Right, as proper ordered pairs. I know this one isn't going to work because it's -2. We can have a negative boy. That don't make no sense. Alright, so I'm going to spread this out. Now, which of these ordered pairs is within the shaded section of both pieces? Should we have two? Oh, so we have two. We do have two. All right, so obviously the black one is out. It's not within both shaded regions. The green one is not within both shaded regions. Now, the purple and the red are both within shaded regions, but as I've already mentioned, this orange one, I guess, orange or red, whatever it's called, we can't have this. We can't have a negative person, right? So we have to remember that this X and this Y are representing boys and girls. Well, if we have boys and girls, we can't have a -2 boy. Alright, so we can't have that number. That number doesn't exist in terms of our domain or range. In this case, we're talking about the Y value, so range. Right, we're not going to be able to have a negative child, so it can't be the orange or red one, so we must choose the purple. The 3025 is my correct answer.